got my message from the weekend about unenrolling in the fall class, and I archived it Saturday morning around 10. So that is done. I went through and tallied up all of your responses. I'd only read through them, hadn't done my data analysis. It looks like more than half of you liked the note sheets, which we have another note sheet today. I'm going to try and do that as often as I can. More than half of you wanted reminders about when assignments are due, and I need some more feedback on that for those of you that requested that. There were 10 of you in this first period class. So please let me know how you think the best way is to remind you. Usually the stuff I give you is due the next day, not always. So let me know, send me an email, post it in the classroom response, but I'm not sure how I can remind you more. Someone in second period, I think, shared that classroom sends you reminders if you haven't done something by midnight the day before it's due, but sometimes I don't post stuff until sometimes it's due the same day. So I don't know. I don't know what to tell you on that one. So give me some clues on how to help you there. I'm gonna do some more reviews. Most of you wanted that, and about a third of you said you'd like to work in pairs more often. So those were the main results. Also, only about 10% of the people, I guess maybe closer to 20% of all 4 classes said they wanted Wednesday office hours. So let me think some more about that, and I will go ahead and schedule some regular office hours on Wednesdays, okay? As far as cameras on and off, about half of you said you liked having them off, not surprising. About 45% of you said handwritten notes, you like that. Google Slide activities, the same as the handwritten notes. Astonishing, almost everybody said they liked the ed puzzles, not every single person, but vast majority, 93 out of 107, that's a lot. And about 65% of you said Kahoot was fun, and about half of you said putting the videos up was good, so I'm going to keep doing that, even though, of course, not everybody looks at them, but at least if you're absent, you'll have an opportunity. The other thing that I really want to thank you for is your honest and thoughtful responses to the academic integrity survey. I did not, so let's see. I can look at individual responses, but it just goes in, just so you know, it just goes in the order of who completed it first, so it's a random order. And I just did a holistic viewing of the answers for the people that responded. And I really, really appreciate your thoughtful responses. Just a question for number 3. There were, I copied and pasted them without names into a document, and there's 14 pages, 7 pages back and front. And I really, made me really happy to see what you guys wrote. So thank you for being people of integrity. I appreciate that, and I'm glad. I hope this helped. Hope this was useful for you. So I see that you took it seriously, and that makes me really, really glad, and I appreciate you for doing that. So I'm going to just share that. Any thing you can tell me right now, anybody, about how to remind you more often? Does anybody have any immediate suggestions? Okay. Well, I'm going to go ahead and get rolling then because I'm not seeing anybody responding. So I'm sure I pick up a couple more people here. All right. Good. Well, thank you again for taking those assignments seriously and giving thoughtful responses. It's really awesome. So in your classwork feed, there should be a note sheet. Today, there it is. So if you want to pull it up, great. If you just want to make a list on your own piece of paper, again, I think that is probably the most beneficial for you to retain the knowledge, have a better chance of it anyway. There we go. So you, I'm sure, pretty sure you've learned that there are what we call periodic families, and there are elements that behave in the same way, and there's a reason for that when they combine with other elements. This was a silly cartoon. The caption's not on here, but something like Bob came home and his parents wallpapered his bedroom to help him with his chemistry class or something. So your parents probably haven't done that, but I thought it was funny. And this also shows the the old numbering system with the A's and the B's. But anyway, what information is on the periodic table? Excuse me. Well, you already know most of it. You know there's atomic number. That's the number of protons. Some periodic tables, not all, give you a hint about their electrons at energy levels. So this is the 1s, this is the 2s and the 2p, and this is the 3s. And when we find sodium on the periodic table, we know it has 2 and 8 and 1 or 11 electrons to counteract the 11 protons. Of course, the symbols on there, the names on there, and the weighted average atomic mass for all the isotopes, which we've already discussed as well. I did not get these for my kids, but you could get periodic table blocks for your children. I'm not, I guess I actually saw a little like 4-year-old, I think she was on Ellen, saying all the names of the periodic table. And she's now like 8 or 9, and her little brother's doing it too. Of course, you can spell words with the periodic table. If you're creative. I've got my chocolate sweatshirt on from back in the day. So families, what are they? Okay, so this is just a generic version of, whoa, I don't know why it's going on its own. Here we go, families. So hydrogen is up at the top of group 1, and then there are the other elements below it in group 1. Those are what we call the alkali metals. Remember, hydrogen is not a metal, it's a non-metal. But most of the time it behaves like these other elements and loses its 1 electron, which we'll be focusing on a lot in coming weeks. Group 2, or the alkaline earth metals, they have 2 valence electrons, and they're also metals, and they lose them. So alkali metals and alkaline earth metals, they get their names because remember, when metals go into water, they make alkaline or alkaline solutions. Middle part of the periodic table, we've already talked about that. That's the transition metals. In modern periodic tables, that's group 3 through 12. So there's 10 of them across. Remember, these are the D block elements. In the old periodic tables, they have this 1B, 2B, 3, 4, 5, 6, 7, and then all 3 of these are 8B. I never got it, never, ever, ever, ever got it. So just know they're the transition metals and they're the D block elements. This is someone's very creative Scrabble board with possible words you can make with the periodic table letters. our symbols. I'm going to hopefully do a jam board with you tomorrow if I can figure out how to make it work. And we'll have a little fun with trying to make some words. All right, boron's family, carbon's family, nitrogen's family, and oxygen's family just get named for the element at the top. The group 17 elements, let me go back to that right here, right, bumping right up next to the noble gases. These are the halogens, like a halogen light. Some of you are familiar with that term. Let me just go back through these again. Boron, carbon, nitrogen, oxygen. The oxygen's family used to have its own name. It used to be called the chalcogens. Didn't stick. So just know those four just go by the name of the head of the family, the top of the family column. Halogens are very, very, very reactive elements. Fluorine, chlorine, bromine, and iodine, super crazy reactive elements, fluorine and chlorine. They are, all of these elements actually are used in cleaning or sterilization. So some of you probably had a surgery where you've been scrubbed with betadine, which is an iodine scrub. Fluorine, you know, we put fluoride into toothpaste and stuff to kill the bacteria in your mouth. Chlorine into swimming pools to kill the bacteria in the water. And bromine is also used in some spas and saunas. Notice that astatine down at the bottom is a metalloid. It's still in the same family. It still has 7 valence electrons, but it is not, it's a little confused. Okay, it's a big atom. And then the last family of the periodic table, again, we've talked about them already a bunch. These are the noble gases. All of these end with the energy level. Okay, I'm just going to go with 3p6, 4p6, 5p6, etc. 6p6. So they finish off an energy level, and then you have to get more energy if you have more electrons. The Goodyear blimp in any dirigible these days has helium in it. Back in the old days, of course, the Hindenburg, you probably have heard of that. If you haven't, we'll talk about it in a couple of weeks. The Hindenburg was filled with hydrogen gas, and very tragic ending on its maiden voyage across the Atlantic. Down at the bottom of the periodic table are the two F block parts of the periodic table. Remember, they are taken out by Glenn Seaborg to make the periodic table easier to read. These are called the lanthanides for lanthanum, the element that starts this, and actinides for actinium. And remember, uranium is the last naturally occurring element. Everything after 92, okay, they're all synthetic. They're all only made in the laboratory, and they're also called trans uranium. Okay. And there's chocolate. So here is our periodic table in all its glory. We've got hydrogen that's really a non-metal, but it's at the top of the alkali metals. Notice there's a little gap here. Alkali metals, alkaline earth metals, transition metals. These guys are just regular old metals. The green ones are the metalloids, like lavender ones are nonmetals, darker blue, noble gases, lanthanides, actinides. And hopefully this isn't brand new to you. All right, the next question that scientists had to figure out the answer to is how come? Why do the elements behave the same way? We can group them together, but why? Why do they behave the same way, even when they have very different characteristics, like fluorine, a gas, bromine, a liquid, iodine, a solid? Why do they all combine with other elements in the same proportions. That has to do with their electron configurations. So just knowing where an element is on the periodic table tells you how many valence electrons it has, and we'll learn why that's important going forward. Okay? So one other piece of information, groups 1A to 7A, which they're actually 1, 2, 12, 13, 14, 15, 16, 17, 18. So 13 minus 10 is 3, 14 minus 10 is 4, 15 minus 10 is 5, 16 minus 10, you get the idea, I hope. And the S block and the P block elements, they are what we call the representative elements. They best represent periodic law. Okay, the law of periodicity. These elements best represent that repeating pattern. Their families best represent that periodic law. Again, they're, oops, that I can't erase. Let's see if I can get this up here. Erase. It's supposed to just be able to click on this, and it's supposed to, nope, that's not going to work. So their S and P sublevels are not filled. Okay, and so we'll look at that here in a second. The group number tells you the electrons added together in the S and P sublevels at the highest energy level. It's a little bit to process, so hopefully this will make sense. Every element in this column, including hydrogen, ends with S1 for its energy level. There's none in the P's, and we could do S1 P0, but what's the point, right? Scientists don't like to write more than they have to, so there's no need to write P0. There are no electrons in the P orbitals. Everybody in group 2, starting at the second energy level, ends with S2. Now, here, remember, helium can be thought of, but it doesn't behave like the alkaline earth metals. It behaves like a noble gas. It doesn't react. Everything in this column ends with S2P1. Okay. 2 and 1 makes 3. This is group 13 or 3A. Everybody here, S2P2. 2 and 2 is 4. Group 4A or 14. S2P3. 2 and 3 is 5. S2P4. 2 and 4 is 6. S2P5. 2 and 5 is 7. S2P6. 2 and 6 is 8. That's our octet. Those are the noble gases that are non-reactive. Now again, it gets a little more complicated in the middle, but remember the S and P electrons are what we call the valence electrons. They're the ones on the outside of the atom. They're the ones that bump into other atoms' electrons. So if you imagine these clouds of negative stuff bumping into each other, there has to be something that happens for them to make a compound. Okay, so again, lithium ends with 2s1, sodium ends with 3s1, potassium ends with 4s1. They all end with 1 valence electron at the highest energy level for that atom. right? Sodium has 1, 2, 3 energy levels. The S is in, there's 1 and the S at the third. Potassium has 1, 2, 3, 4 energy levels. The 1S is in the third. So you're going to feel like a genius after this, I hope. All right, so again, just some information, some kind of tie it in here. Sodium, this is Death Valley, the salt. There's actually multiple salts, but sodium chloride is part of the compound. Excuse me, sodium is part of the compound sodium chloride. And then magnesium is also often in things. This is a picture of trying to show chlorophyll. But of course, magnesium also is part of the hard water you have coming out of your faucets that leaves the crusty white stuff, calcium and magnesium both. So group 4, carbons family, 4A, which is group 14 now, okay, has 4 valence electrons in the highest energy level. 2 and 2 is 4, 2 and 2 is 4, 2 and 2 is 4. So carbon, silicon, germanium all have 4 valence electrons. Arsenic is in the next group. Arsenic's in, where's the pen? There it is. Arsenic's in group 15 or 5A. Arsenic is a poison and it actually is in a lot of water supplies as well. It is in the 5A, that means it has S2P3, it has 5 valence electrons. And sulfur is in 6A, that's oxygens, oops, sorry, there's sulfur right here. It's oxygens family, it's in the 1, 2, 3, 4 column of the P block, so it ends with S2P4. It has 6 valence electrons. And then, of course, group 8A or group 18 of the periodic table, these are the noble gases, and they all, like I already said, in S2 or S2P6. Okay, 2 plus 6 is 8. They have filled their valence electron orbitals. So again, just knowing what line it's on, 1, 2, 3, 4, 5, 6, 7, you know the energy level, you know the principal quantum number, knowing where it is on the periodic table, oops, you know what block it's in, what type of orbital the last electron goes in. I'm not drawing very straight, forgive me. And knowing what column it's in tells you what number of electrons are in those p orbitals or s orbitals. And again, we could have periodic tables all labeled for you, but it's not necessary. Okay? So everybody in here ends with S1. Everybody in here is S2. Everybody here is S2P1. S2P2, S2P3, S2P4, S2P6. Just to finish this up, transition metals, remember there's 2, this is an old name, they don't call them this anymore in most books, but transition metals, just remember that the lanthanides and actinides are what used to be called the intertransition metal. They also used to be called the rare earth elements, even though they're not rare. Just remember they're metals. Okay? And they also are classified based on their electron configurations. Okay? So transition metals have S's and something in the D's. The lower ones have S's and something in the F's. And this is the information on, oops, I forgot to take this slide off actually, I thought I did. Okay, so again, you can look at your periodic table in a number of ways, but each column tells you about how many valence electrons, S and P orbitals, and then again, these transition metals get a little bit messy with their Ds. It's bananas. All right, so let's try a little review, see how we do. Quiz yourself as you go. First column, alkaline metals. Second column, alkaline earth metals. Middle columns, transition metals. Boron, carbon, nitrogen, oxygen. Group 17 is the halogens, noble gases, lanthanides, and actinides. Chemistry makes you think. All right. We could do this, I guess, but I'm going to let you go. I think that's enough for today. I would strongly encourage you to make sure you've got this filled out and make sure you know where these elements are. Oops, I took this off, my bad. Okay, so I'm saving that for another day. Make sure you know these group or family names and make sure you know the key point. They're based on their electron configurations. And I am going to find our meeting and stop presenting and stop recording.